to get you caught up, I'm sure.
Oh, I put my thumbs up, but you were talking.
Okay,
and then...
we're good?
Yeah.
Okay, so Kimberly, what does it mean? Area bounded by four things, right? And these things are, David, what are some of the things? What are some of the bounds? The area bounded by... No. This represents area. Area bounded by four things. What are the bounds, David? The x-axis. Give me one more thing. The x-axis and? And the graph of f of x. Anthony, what are the pieces that he didn't tell us? The vertical lines x equals a and x equals b. I need trapped area. I need all that total area. It's the bounded area. So if I happen to have a graph in front of me, here's f of x, here's x equals a, here's x equals b. All the side conversations need to end. That's when I start to go circus boy crazy. So that's what it means. Now I want to get some vocabulary going here. What are the things? Let's get some hands. What are the pieces that you know? Edgar?
The squiggly line is the integral sign?
The squiggly line, which we're going to refer to as the integral. Yes, the integral. Eunice, what else do you know? B is what we're going to call the upper limit of integration. I can only see an arm back there. It must be Rombier's.
It's Noemi's.
It's Noemi's. What else?
A is the lower limit of integration.
A is the lower limit.
Come on, Mr. D, you know my arm.
I know your arm's up there, Rombier. What you got for me? We got the integral, we've got the upper limit of integration, we've got the lower limit of
Oh,
integration.
that's the function.
Oh, good, it's the function. But when I take the f of x and the dx together, Jasmine, what do we call that? The what? Nope.
Integral.
Integrand.
Oh.
The integrand. The integrand. There's one more thing.
Tragic.
There's one more piece that I care about. Adriana, what's the last piece?
I think it's dx is the variable of integration.
The dx is there to tell you what your variable of integration is. And I'll tell you right now today, just about everything that we've done so far, the variable is going to be x. That is not always going to be the case. Pretty soon I'm going to switch it to t's and thetas and w's and all the things. Is everybody okay, first of all, with what it means? And we're okay with the vocab? Good. So let's go back to where we were yesterday. And somebody want to drive the computer? Okay. Oh, that's right, because I had you do it yesterday, but you just sat back there. All right, so click on the hide trapezoids. Okay, good. All right, so for this particular problem, the one that we looked at yesterday, I think we were going from 0 to 6 f of x dx, right? This is in yesterday's handout, which you need to find.
Oh, we need it?
Yep, you're going to need it.
Yeah.
The one we did at the end of class yesterday, we were talking about, I forget which method.
Left endpoint method.
Left endpoint method.
I know.
Okay. So the gray area represents the shape. It represents the region that I want. I'm definitely trying to do this to get the Jennifers caught up. Okay? So I've got the region, I want to find the area of, and this is going to be more of a challenge for us. Why? Why is finding this area going to be a challenge? I see Noemi, I see Jasmine. Why is finding this area going to be a challenge? Edgar, why is it going to be a problem?
Because it's curved.
Okay, we've got a curve. Now, if I had gone all the way from 0 to 8, would we be worried? Would we be having a problem?
No.
Christian, why not?
Because we would just find the area of the whole circle and just divide.
Right? What we talked about is this curve is actually like the top half of a circle. So you could say I could find an area of a full circle and cut it and divide it by 4. But I'm not going all the way from 0 to 8. I'm going to go from 0 to 6. And the last time I checked, this region here from 0 to 6 doesn't actually have a name. It doesn't have a name and it doesn't have a formula. And yesterday we did left endpoint. Okay, so Rambier, what I want you to do is show me the left rectangles. And you guys should have in your notes, it looks exactly like this. We were going from 0 to 6. We cut up the interval, but the fancy word I used yesterday was partition.
No.
Partition. It just means I'm chopping up the interval. The interval, stay with me,
The interval.
is from 0 to 6. The partition is how I'm chopping up the interval. And for the Jennifers, with the left endpoint method, all we did is we said, okay, if x equals 0 is the left point, I'm going to go up to the curve, over, and down to determine the first rectangle. For the second interval, it's at 1.5 and 3. At 1.5, up to the curve, over, down. Up to the curve, over, down. Found the area. I think with this class we got to do this on the calculator. And life was good. Run beer.
So when you say partition, does the partition equal 1.5 or is that just like labeled?
No, the partition represents where are you making the cuts.
So is partition just a term or?
Yes, the partition is just a term. The partition is how are you chopping up the interval. The 1.5 represents how wide. There are no bad questions. Everybody good? Okay. Hide those rectangles. What I want to show you is another method that Riemann pioneered called the right endpoint method. Trust your instincts here. What's going to happen after Rombier hits his button?
It's gonna go to the other side.
From within.
It's going to
I'm going from 0 to 6 and I'm going to use the right endpoint method. Look at those rectangles. My partition is still the same. What's different with the right endpoint method? David, what's different?
Instead of having the rectangles go over the graph, they're staying below the line?
They're staying below the graph because my partition is 0, 1.5, 3, 4.5, and 6. And this is the part I'm actually going to want us to do this on the calculator. If I'm going to find the integral from 0 to 6 of f of x dx, I'm going to approximate. It's not going to be an exact answer. The right endpoint method, you guys all raise your right hand. I want to make sure. I'm always amazed how many of the seniors actually don't know this one. It's this one. From your perspective, this one. The right endpoint method means if I'm choosing between 0 and 1.5, choose the 1.5. So I'm going to go up to the curve, over and down to make the first rectangle. Up, over, down for the second. Up, over, down for the third. In terms of finding the area, I need to find the area for each rectangle. So for the first rectangle, how wide? 1.5. How tall?
8.
That's
Around 8.
Okay, all right, so I'm hearing a whole lot of different things. I heard some folks saying 8.
Oh, f of x.
Oh, F 1.5.
8 would be the exact y value, but for the left point. All my 7 and some stuff people, what I think you're doing is you're estimating the y value, and we have a better way to do this, Jose, don't we? What's the better way? You're going to plug the 1.5 into your calculator, right? So we're going to have 1.5 times f of 1.5. And I don't even want you to do it yet, because we're not interested in that. That's the first rectangle. Can somebody tell me about the area for the second? Let's get some hands on this. Tell me about the area for the second. No, Amy, what's the area for the second one going to be?
1.5
Plus that 1.5 again.
f of 3.
Times f of 3, because 3 is the right endpoint. Up, over, down. Somebody tell me about the third one. Third one, Eunice, what you got for me?
plus 1.5 times f of 4.5.
1.5 times f of 4.5, because 4.5 is the right endpoint. And that last one, Jonathan, tell me about that last rectangle. 1.5 times f of 6. Everybody okay?
Yeah.
Okay, before you do the calculations, overestimate or underestimate?
Underestimate.
That seems pretty consistent, underestimate? Adriana, why underestimate?
Because you're not getting the whole area, because the rectangles don't cross the curve of the line.
Right, the rectangles are not capturing all the area. This time I've got this area that I'm missing, so I'm going to have to get an underestimate. So, why take attendance? Get the answer on your calculator. Now, in order to do this cleverly though, you have to have on your F1 square root of 64 minus x squared. So if this is not the graph that you have on your calculator anymore, make sure you put that in. 3, 7, 11, 14, 16, 21. Oh my god, full house.
Let's do this one, right?
Quick, and then you're back.
And what are playing
Okay, I'll just make sure I didn't follow.
It's turning right now.
So we don't.
Check the.
Mr. D.
It's at 4 rectangles.
Mr. D.
Yep.
For the thing, it didn't show up. That's right.
Okay. What'd you get for your 40? 40 bucks.
And then you just put bar or calculate, right?
Yeah, just want to look up.
And then you.
Hey, John.
More stuff.
Yeah, with those two.
Uh-huh.
They're off by
So what'd you get? 44 point.
44.833.
Because it's an underestimate.
Wait, 44
Yeah,
point.
the one yesterday.
0.770.
Okay. How many guys are getting 44.7703? Or 44.770? Oh, 40.
Yeah.
Okay, one more time. 40.770. Life is good. Your calculator's doing the heavy lifting. Now, I want to make your lives even better. I know you never actually think that that's what I'm trying to do. But I want to make your typing lives better. Anybody see a way to make your typing lives better?
Oh, well, I don't.
What could you do?
Oh.
What could you do? Marvin, I saw you first.
1.5 to the power of 4.
1.5 to the power of 4 would be a disaster.
Oh no. 4 times 1.5. 4 times 1.5.
4 times 1.5, because there's a 1.5 here and a 1.5 here and a 1.5 here. Also a disaster. What do you say?
Not very.
So we've got 1.5 times f of 1.5 and 1.5 times f of 3 and 1.5 times f of 4.5 plus 1.5 times f of 6, Jose?
Oh my goodness.
How about factor out that 1.5? Is that legal?
Yes.
Now look what happens. If you factored out the 1.5, now you've just got f of 1.5 plus f of 3 plus f of 4.5 plus f of 6. You're going to type in that 1.5 a lot less than you had to do the other way. Life gets much, much better. Now, my friend George Riemann, we weren't actually friends. He died before I was born. But, you know, theoretically. George Riemann got all of this fame not because he could work with 4 rectangles. 4 rectangles are good. But if you want a better estimate, this is worth a baby food jar.
You put more rectangles.
No, it's not. It's not disgusting. Because last time I checked, there is a food drive going on campus right now. And baby food is very much needed.
I'm the plug guy.
So for really good, insightful questions for the next couple of days until I run out of baby food, really good, insightful questions get you some baby food that you can then turn around and donate to your base camp.
Are they
So-
expired?
No, these are fresh. These are fresh. So 4 rectangles gives you a good estimate. But 5 even better. Rambert, hit the n+1 nonstop. I want you guys to just check it out.
Should I hit the high?
No, just let it go for a little bit. More rectangles. Here's the actual area. Here's the estimate.
It's getting closer.
More rectangles means
A better estimate.
it means like you're more chopping, right? More partitions. It means that the rectangles become narrower. But look at the error. The error is almost invisible. You're getting super close.
This 40.
I see you're tempted, Rambert. There's another button that you want to hit? No? Oh, I thought you wanted to do the n+10.
Oh, I'll do that.
Okay. So now rather than increasing by one at a time, we're going like from 48 to 58 to 68 rectangles. Good news, we're going to do that later this week.
Not today.
Not today.
It moves up by 0.001.
But really, Riemann didn't get his fame because he could work with 100 rectangles. He went best case ever.
A million.
Not a million. That would be good. An infinite number of rectangles. And on Friday, we are going to play around with an infinite number of rectangles. I can't wait. All right, so right now, let's hit the n+10 nonstop. Double click on this number and hit n = 4. Double click over here, n = 4. We've got 2 methods so far, right? Martyr, what are the 2 methods that we've got? We've got the left endpoint method, we got the right endpoint method. Okay, can you show, hit the hide right rectangles? Show midpoint. Show midpoint. Have a conversation with somebody near you. What's different? What's different?
Oh, you're never right. Oh, yeah, they have the same way.
The interval is still going from 0 to 6.
Right?
Hey, is it
You go from 1 to 1 and 10.
You go to
Right, and then go right to the line.
All right, let's pull everybody back together and 3. And 1. What's different? Adriana? Let's see, Giselle. Just 2 people? Giselle, what's different?
It's a bigger width.
It's a bigger width. Actually, I'm still going from 0 to 6.
Yeah.
There's still 4 rectangles of equal width. They are not any wider than they were before. What's different, Adriana?
The midpoint of the width of the rectangles is what's touching the line of the circle.
If you look at any of these rectangles, so like over here is 0 and over here is 1.5, the midpoint method is well named. You're going to take the midpoint of the interval, go up to the curve, over to the left, over to the right, and come down and make your rectangle. Anybody see why you would choose to do this? Look at the graph. Why might the midpoint method work really, really well? Daisy, what do you say?
Is it because it covers more area of the circle?
Covers more area?
That white shaded part is the same as the underestimate.
You've got some area over here that you're missing, that you're not capturing. You've got some area over here that you're capturing that you don't want, and it looks like that they might cancel each other out. Now here's the thing. No guarantees that they cancel out. In fact, if I look over here, the actual answer is 43.040. The estimate is 43.145. Not bad at all. For 4 little rectangles, this is not bad. But the key is you're getting some underestimate, you're getting some overestimate, and so you're getting some of that to cancel each other out. So this is a third method. There's one more. Can you hide midpoints? Show trapezoids. This is my favorite method of them all. There's a really, really good reason why this is my favorite method. I mean, look, you've got 4 trapezoids there that are almost perfectly capturing the area of this circular piece. The trapezoid method usually gets you the best estimate with the least amount of work. It gets you a strong estimate really quickly. Questions so far before we do any practice problems?
Where's the trapezoid?
Where are the trapezoids?
Like, there's no white sheet area.
The trapezoids are here. Like these guys here are the bases, and then you connect them. There's a trapezoid. A very badly drawn trapezoid on my part, but that's your trapezoid. The bases are going this way. We kind of okay? So talk to somebody near you. What are the 4 methods and how are they different? And Rami, are you good with staying back there, or do you want me to rotate somebody else?
It's a midpoint
So we're
method.
gonna switch over to the top.
That's when there's an overestimate and an underestimate. And they cancel out like how do you add calculator? Oh.
Yeah.
Yep.
Could you go over midpoint again?
Perfect, 'cause that's exactly what we're gonna do. Alrighty. Riemann, 4 methods. Let's get some hands on this. What are the 4 methods? Oh, so awkward. So awkward. Anthony, give me one of the methods. You get the left endpoint method. What else?
Right.
What else? What else? What else? What else? What else? Jennifer? You've got the trapezoid method. Daisy, what else you got?
The midpoint method.
You get the midpoint method. Jose, close it out. What do you got?
Trapezoid.
Trapezoid. Thank you, Jose. Sorry, Jose. I'm so excited like when we start talking about George Riemann. All right, so let's move forward. We're going to do a lot of calculations. You complete yesterday's handout away. We're switching over. You guys are about to get a lot of calculator practice. You've got a new function coming your way. And can I get some brave soul? Abraham, could you read the introduction? Riemann? Don't worry, he's dead. He's okay.
Bounded by a function f of x and the x-axis over an interval from a to b. Today we are going to continue down the same road that we traveled over 150 years ago. The idea was simple enough to estimate the area bounded between a function and the x-axis over an interval. Divide the interval into smaller sections and then create known geometric shapes to estimate the area of the smaller intervals. Then find the sum of the areas. To get a more accurate answer, make this sub-interval smaller, then smaller, then smaller, then smaller. How small is that? Last one.
It's infinitesimally small. What's the word? Infinitesimally small. Abraham, whenever you're tired of reading, just call on somebody else to pick it up from there.
As the lengths of the sub-intervals become smaller, the number of intervals must become larger and larger and larger and larger. How large is the last one? Infinitely large. The final result then will be the exact value of the definite interval. Wow. If this wasn't impressive enough, we did all of this without a calculator.
Yeah. We did all this stuff without the calculator. We are going to use our calculator from start to finish. So Noemi had a request, and it was a perfect request. She wanted to do one with the midpoint method. Let's do the first one with this midpoint method. To get this started, you're going to need to graph the new function on your calculator. And Jasmine, do you remember how to do all this on your calculator? And you're going to be able to show Jennifer? And ladies, you guys are going to take care of the other Jennifer? Perfect. Okay. So I want the midpoint method. Rambir, can you hit escape so that this window goes away? Just hit the escape. Or the escape.
Okay.
There you go. Okay, get yourself a good graph.
No, just put it here.
For those of you that have already got this graphed, I think it would be a good idea to find what's the exact value from 0 to 6 of f of x dx. Just want to make sure that you've still got those skills as well.
Is there an endpoint thing here?
Is there an endpoint thing here? Okay, don't do it on, you can do it on the graph. Do it on the calculate screen instead.
Oh, okay.
So Ranbir, if you could hit the toggle button,
No, what button?
this guy over here,
Okay.
and then just hit enter or delete out all the stuff that Josue was just typing. And then Ranbir, do you know how to remember how to do this?
Yeah. There are multiple. I found another way. Can you
Yep.
do this?
Yeah, you can do the templates button. That works too. And then we're going to go from 0 to 6. And if you've already graphed the function, you can just type this in as f1 of x. But you have to do f1 and then in parentheses the x. With respect to x, hit enter. And if all goes well, according to our calculations, 19.504. Can I get a thumbs up if you get 19.504? Okay. The 19.504 represents the actual area. What we're going to do is we're going to do the midpoint method to approximate. So right here, let's switch back to the graph. So we're doing the midpoint method. How many rectangles? It'll never be on my face.
4.
You definitely want to look at the page. Midpoint method. We are going from 0 to 6. That's the interval. But how many rectangles?
4 rectangles.
There's n equals 4, and there's something else about these rectangles that's special. They are equal width rectangles. And I will tell you, our friend George Riemann did not need equal width rectangles. We are not always going to have equal width rectangles. But if you're just thinking about your partition, I'm going to go from 0 to 6. I want to figure out the width. So I'm going to say 6 minus 0 divided by 4, 1.5. Okay? Yep, Ranbir, what's up?
To get 4, are we just using that as a standard number?
Right now, we're gonna use 4, but some of the problems you guys are about to do have a different number of rectangles. Yep.
Does the problem always tell us?
They will always tell you in the problem the number of rectangles. Okay?
Where did
What's the question?
Did it tell us?
Yes.
They didn't write it in.
Okay, so my question, I think this is just good practice. What's the partition? Where do I make my cuts? The width is 1.5, so I start over here at 0, and then I'm going to end at 1.5. And the next one?
3.
3, and then the next one?
4.5.
4.5. So if you're doing this on the graph, you're like, okay, here's 0, here's 1.5. We're not going to get all OCD, right? We're just going to eyeball it and say, okay, fine, that's my 0 to 6, that's fine. Here's where we need to be careful. The midpoint method. Last class, I think I made some big assumptions about our ability to find midpoint. If on this interval of 0 to 1.5, I asked you guys, where's the left point? You'd say, wait, one more time. The left point is 0, and the right point is 1.5, and the midpoint
0.75
is halfway in between, right? So it's 0.75 that I'm interested in. Between 1.5 and 3, the midpoint, this is where things start to fall apart. The easy way to find midpoint, add them up, divide by 2.
2.25.
And you've got a calculator in front of you if you need it. 1.5 plus 3 is 4.5 divided by 2, 2.25. Next one, between 3 and 4.5 is 3.75. Between 4.5 and 6, 5.25. If those numbers are not coming to you comfortably, add, divide by 2. Add, divide by 2. Okay? So let's draw the rectangles. The significance of the 0.75, that's going to be where I go up to the curve and I say, that's how tall my rectangle is. And I go over to the left, I go over to the right, and I make my rectangle. That's the first rectangle. Determined by finding the value of the function at 0.75. From 1.5 to 3, at 2.25, I'm going to go up, over and down. At 3.75, over to the left, over to the right, and down. 5.25, over to the left, over to the right, and down. Those are the 4. If I want to actually get the area, I just need the area for each rectangle. I know I'm going a little fast, but I think you guys are going to be okay. If I look at this first rectangle, my question is, how wide? How wide is this first rectangle?
1.5. No, 0.75.
How wide is the rectangle? The rectangle has to go from 0 all the way to 1.5, so the width is 1.5. How tall? This is the tricky question. If it was the left endpoint method, you guys would tell me f of 0. If it was the right endpoint method, you'd say f of 1.5. But it's the midpoint method, so f of 0.75. It's the midpoint that you use to determine the height of the rectangle. So it's going to be 1.5 times f of 0.75. That gets you the area for the first rectangle. Can I get some brave soul to tell me the area for the second rectangle? What's the setup? How wide, how tall? Jonathan, how wide, how tall?
1.5.
1.5 is the width. Are you surprised that 1.5 is the width? Why not? They are all the same. How tall? F of 2.25. Jose, how do you feel about this third rectangle? Could you tell me how wide and how tall?
3.75.
Wait, careful. What did you say?
1.5 times 3.75.
Now I heard 1.5 times 3.75, but what you really mean is 1.5 times.
F1.
Or we're just going to write f of 3.75 because that's the height. All right. How do you feel about this last rectangle?
It's 1 point plus 1.5.
Plus 1.5 times
f of 5.25.
f of 5.25. And if you made it to there, good news, all you have to do is type this into your calculator. And for those of you that don't like typing in the calculator, be clever. Be clever if you can. Factor out that 1.5, and so now it's f of 0.75, f of 2.25, f of 3.75, and f of 5.25. Pop that in the calculator, let me know when you think you got it.
Is it 90?
It's not going to be exactly 19.9. I need 3 decimal places though. 19.647. Looking for at least 4 more people to get that right value. What do you think? Okay, get another person. Ian, what you got? 19.647. 19.647 and some stuff. 19.6479. As long as 3 decimal places, we're good. How many guys get 19.6479? Or 19.647 and stuff? Nice. All right, I want to put 10 minutes on the clock to give you guys just some practice time. Yep.
So when drawing these rectangles, you want to make sure that the midpoint of your rectangle intersects with the actual function.
Right, that's how you determine the height. You use the midpoint and you go up to the curve. Okay, so I'm going to put 10 minutes on the clock. Your goal is to work through method 3 and method 4. It's a left endpoint method and a right endpoint method. I just want you guys to get some calculator practice time. whoever's birthday is closest to Christmas, you're the one in control of the cuts. Yes, sir.
Check the settings.
Do I just go to the new document and grab it?
Oh, wait, no, you should
Wait, where were you? Were you on a
Try this.
First you have to decide to use the rectangle. No, first you grab the thing.
John, that's beautiful.
Every time I go to my computer, it's from here.
What?
Isn't it unit squares?
Don't assume.
Good question. If you want to be very, very precise, you should probably use units.
Okay, so I do this and then I do this one.
But you would say unit squared because it's easier.
And how do you get this?
Trust me, we are
Yeah,
going
now you're confusing me.
That's why
That's why I don't
you should start in the copy notes. It's like that's where you start. Because you already have F1, you already have like F1.
I know you start at graph, but what if I put this?
No,
Oh, no, just put the equation. Yeah. This is just telling you that it's from 1 to 6.
a lot of calculator work happening.
Okay, and after this, what did I do now?
You already have the
So we've already got the graph.
And then I just go here.
The right endpoint.
What do you say?
Yeah, right endpoint. No, like the answer.
Is it?
Sir.
What happens to the plus 2? We just dump it in?
Wait, okay, so for right endpoint class,
Oh, that goes for this?
You didn't, you started from 1.5, not 0, right?
Because you're using
Yeah, so then you start with 2.
No, it's like from 6.
So wait, hold on. You're going from 0 to 6. What we're saying by the right endpoint method is once you have your smaller and
19.5.
your first interval goes from 0 to 6.
That's the right end. So once you find the partition, you know it's from 6 to 4, right?
then you have to do the
So I would label this as the first rectangle.
Okay.
I know what you guys are doing. It would all work out equal. This is the first rectangle. The width is 2,
So you
the
have to
height
go from
is
0 to
F.
6, and then you have to divide the rectangle.
The width is 2, the height
I
is
did do it for my
F.
first one. My 5 and 6 and 7.
It doesn't, the right endpoint doesn't mean I'm starting all the way over here at 6 and working my way to 0. The right endpoint method is once I've partitioned my interval, once I've chopped it up,
No, 2. No, 2.
use the right side to determine the height.
You want this one to start up here, the first one? But our first, but the number 1 has to reach right here.
Oh, they should all be close.
That's what I just asked him. I said, the midpoints have to reach the center. This is right.
That's, this is the right, so we
So
start
when
here.
drawing
we
this,
just put
is this right here? Supposed to stop up here?
So which method are you using? Right endpoint. So your first interval goes
So
from 0
they're gonna be like that?
So our right endpoint has to
Right, so it's the right.
Oh, okay. It's underestimate, right?
Yeah.
So what was the first one?
Oh, I messed up.
Oh, okay, right.
Okay.
So that's good, the diagram's good, and at some point the three of you are gonna be like, I don't want to do this. I want to do it.
Oh, I'm using the wrong
You need to draw the rectangles when you realize.
We're not using the same one. So there's not both of them stop down here?
I got 19 from 30. I thought the same. Like, I
And then 6 should stop down here.
The rectangle.
Wait, how did we do
this first.
After that, we just
So like,
What do you
right
have?
here, the width is divided by 1, and then you use this point. Right here I have the curve. I mean, you can write that, I just have
oh yeah, 2.
It's still a while now.
Oh, yeah, it's the same
All the time, so it's basically 2 times.
Oh, okay. So it means
4 plus 6.
For what? The thing.
We're on camera, you guys. We're on camera.
We can't talk about it now.
Gotta go.
I'll tell you after.
Relax.
Okay, how are we doing?
I don't know how to do
Jose,
it.
where are you?
1.25.
8 now. It's 0.8.
Okay, I need to see all the
It's
words.
1.25.
No, on the paper, I need to see the words.
6 to 2.
So I would look at this and I'm gonna say, this answer is worth 3 points. 1 point because you have the width of the rectangle correct. Another point, you're determining all the heights correctly, and then a third point for the number answer.
So can we just like do it on the diagram?
That's, ideally, you're gonna write it this way. Okay?
Yeah.
Yep.
I don't know how to divide it into this.
Sure you do, you just did.
4 or 5.
Each rectangle has a width of 0.8. So you're gonna start at 2 and move 0.8 spaces to the right. Okay?
2 would be 0.8. Right?
Yeah.
Just add 16, it'll be 8.8.
8.8.
So it'll just be at 3.6.
Oh, wait, that's your estimate there. 19.38.
Why did they put their camera like facing over here?
Then a 4.4.
Because
Is that where our line is going to be?
Yeah, 2, yes.
2.8.
No, a 2.
That's 2 from 6. Yeah, that's
Yeah, the line is a 2, not you said 2.8.
All right, let's pull it together. Ramir, if you could go back, all right? If you could turn the camera around.
Oh, it's basically the same thing.
Okay, we've got one last method. You've seen it, but we haven't done it. So if you could pause on wherever your calculations are. Ramir, if you could switch back. Thank you very much. Oh, I love it when that happens. Perfect. All right. All right, the last method. I care about getting this set up. The last method, this is method number 2, is trapezoid method. So if you look at method number 2, let's make sure we know what integral we're finding. What's the definite integral? From where to where?
1 to 6.
Oh, it's from 1 to 6. Same function?
Yeah.
Okay, things that I care about. How many trapezoids?
4.
Okay, 4. One of the problems you guys did, I gave you like 5 trapezoid or 5 rectangles. The other one was 3 rectangles. In terms of your homework and what you're going to do in terms of computations, I'm going to keep the number small because you're going to have to actually find the area for each one. As we go throughout the course of the week, we're going to hit the infinite case, which is really exciting because no calculators. I know, Jose, I can't wait. So, 4 rectangles?
Yes. Trapezoid.
4 trapezoids. Still equal in width, right? Okay, so first of all, let's draw them. And at some point, all 21 of you are going to decide you don't want to draw the trapezoids. Whatever point that is for you is fine. You're not going to get any points for drawing the trapezoids. So I know I'm going from 1 to, let's call it 6. First question, how wide's each trapezoid?
1.5.
Oh, not 1.5, no.
1.25.
Right, the 1.5 folks are thinking they're going from 0 to 6. We're going from 1 to 6, so pay attention to your interval. So we're gonna say, oh, that's 6 minus 1 divided by 4, which is 1.25. I have really become a fan this year of like doing my little interval and doing the chopping over on the side so I can see it. If I start at 1, I'm going to chop into 4 equally widthed ones. I start at 1, the next one is 2.25 because I just moved 1.25 spaces to the right. The next one? 3.5. The next one?
4.75.
4.75. So what that means is my cut points are at 1, 2.25, 3.5, 4.75, and here come the trapezoids. Here they come. With the left endpoint method, you would say start at x equals 1, go up to the curve to determine the height, come over, come down. With the right endpoint method, you'd say 2.25, go up to the curve, come over, come down. Midpoint method, you'd find the midpoint wherever it is between those two, go up to the curve, over and down. Trapezoids, you use both x equals 1 and x equals 2.25. These guys here are your bases. Stay with that thought for a second. You're going to make the trapezoid by connecting those 2 points and that guy there. There's trapezoid number 1. Yesterday when I drew the trapezoid, I think I drew it this way. And we said those are the bases because the bases are parallel. And here's base 1, and here's base 2, and here's the height. And in that case, you say the area is 1/2 base 1 plus base 2 times height, and you guys did a great job with that yesterday. Now your bases go this way. So there's a base and there's a base. And this guy here is the height. Your trapezoid's going this way. So let's set up the first trapezoid. It's going to be 1/2. How long is the first base?
1.25.
No, the height is 1.2.
How long is that first base?
F.
It's f of
F of
1. You use x equals 1 to go up to the curve. This guy here is parallel to that guy there. So don't worry, we're going to get lots of practice. 1/2 f of 1 plus the next base is at f of 2.25. 1/2 base 1 plus base 2 times the height. The height is here. Right? I know it's weird to call height and it's the part that's laying down, but for a trapezoid, the height is the perpendicular distance between the sides. So what's the height? 1.25. That's your first trapezoid. When I go to the second trapezoid, I use 2.25 and I use 3.5, go up to the curve, connect them. Can I get some brave soul to tell me your area setup for the second one? Jonathan, what's it going to be?
1/2
1/2
times f of 3.25.
f of what?
3.25.
F of 2.25?
Oh, yeah. Plus f of 3.5.
Plus f of 3.5. 1/2, that's a base, that's a base. What's the height? 1.25. That's your second one. Somebody give me the third one. Edgar, what's the third one going to be?
1/2.
1/2.
F of 3.5
F of 3.5.
plus F of 6.
Oh, you made a big jump there.
F of 4.75.
F of 4.75.
All of it times 1.25.
All of that times 1.25. So there's my third one. Love it. Last one. Last one, Abraham. What's that last one going to be? 1/2
times
f of 4.75 plus f of 6. What I like about these, you start to figure out the pattern and it clicks. Now, I have no doubt every single one of you can type this into your calculator and get the right answer. I'm going to be awarding points probably for seeing the 1.25 that tells me that you know how wide each one is. And all this setup is going to be worth probably one more point, maybe two. One more point comes from giving me the number. But I want to be clever. Love being clever. Anybody see clever stuff that'll save you typing time? Jennifer, what do you see?
You can factor out the 1/2 and the 1.25.
Is everybody okay with factoring out the 1/2?
Yes.
Because there's a half here and a half here. Oh, awkward, I'm using my check marks for different things now. I just factored out a half. I think we can do more than that. Rambir, what else?
Factor out the 1.25 and then multiply it by the half.
Okay, hold on. So you get the half and everybody's okay, we're factoring out the 1.25? Now, what's left?
The
Here's where things get really exciting. What's left?
F of
F.
F of 1 plus
Oh, F of 2.5.
F of 2.25
Times 2?
Plus F of 3.
F of 1
2.5.
plus F of 2.25
Times 2.
Plus it
F
again.
of 2.
plus again F of 2.25 plus
2 times 3.
F of 3.5
Times 2 again.
and again plus F of 4.75 and again. Hold on. Oh, yep. Plus F of 6 one time. The first base gets used once. All the other bases get used twice. The last base gets used once. For those of you that are like, oh yes, I like this when I see it, you are welcome to do this. As long as the widths are the same. The widths have to be the same for this factoring thing to work. If you don't see it, or if you're like, brain's full, show me each one of them separately, it's all good. Okay, tonight's homework. Let's just look at this real quick. Tonight's homework should not take